Hi, good morning. I'm going to share about molecular thermal energy storage system. Energy storage system is a vital part of renewable energy system. Systems such as solar, wind, and pumped water storage systems require a storage medium to store the generated power and release whenever needed. When we think of energy storage systems, solar energy storage, battery, and electrical storage mediums such as capacitors, supercapacitors, superconducting electrical storage systems comes into our mind. The choice of the energy storage system depends upon the application, the economics, the integration with the system, and the availability of resources. Thermal energy storage systems are the simplest and the cheapest energy storage mediums that are available in the present. Energy storage, like energy thermal energy storage system, is the simplest and the most cost-effective technology available at present. With the use of phase-changing materials in thermochemical energy storage system and the technology used for recovery of latent heat are promising for seasonal energy storage, but it is still debatable whether thermal energy storage systems can be used for a long-term energy storage. If we take up a battery, capacitor, or supercapacitor, the maximum lifetime is limited to 15 years. The number of cycles of charging and discharging decides the lifespan, and it is still a question whether their lifetime can be extended further. With the objective of storing the energy for a longer period, Chalmers University of Technology, Sweden, have developed a molecular thermal energy storage system called as MOST. MOST system is based on molecular structure capable of capturing solar energy at room temperature and storing it for a longer period. It is a closed cycle of energy capture, storage, and release. A zero-emission solar energy storage system can be built with the MOST. Materials like organometallic compounds can be used for energy capturing. Let's see how MOST system works. The MOST system consists of a working fluid, a microfluidic solar collector, and a catalytic heat release reactor. The working fluid contains a compound called as fluvalent diruthenium compound. When it is exposed to sunlight, the bonds between the atoms of the compound are rearranged, turning it into an energy-rich photoisomer. The energy from the sun is then captured into these strong chemical bonds. The compound 1 is photoconverted in a high surface area solar collector to form a second compound, which is 1-dimethyl tridecyl compound. The compound 2 can be pumped directly into a heterogeneous catalytic converter in which the stored energy can be extracted as heat by a heat exchanger. The same working fluid can be pumped into the MOST and can be reused where it would collect and store solar energy again. The high solubility of the newly synthesized compound provides a large energy storage density in the working fluid, and the catalytic energy release reaction is rapid. The energy can be stored for a period of 18 years with the MOST system. In the liquid's peak capacity, the MOST is capable of storing up to 250 watts of energy per kilogram, nearly twice of what a Tesla Powerwall battery can do. The MOST is a new way of using solar energy to generate power. It means electricity can be generated from solar regardless of weather, time of the day, season, or geographic location.